Yeah. Before we kick off, thank you for inviting me. Before we kick off, thank you for inviting me. I'm not sure entirely. I think, even though I live in the Netherlands, you live in the Netherlands, I think this meetup was arranged through some people in Australia. I tried to explain that to someone else. How did you end up speaking at this meetup? And I think this was because of Matt.
Yeah.
If I remember correctly.
Yeah.
So for those of you who don't know, Matt is one of the founders and core contributors to the Pact, the Pact suite of contract testing tools. And I think Acharya originally approached Matt to do a talk, and he said, well, there's this guy in the Netherlands, and time zone wise that would be much more efficient than me joining in the middle of night for a meetup on your end. So yeah, thanks for having me, thanks for inviting me. My name is Bas Dijkstra. I am a test automation consultant and trainer. As I already said, like Acharya and Sandeep, I live in the Netherlands. I've been in test automation for some 15 years now, I think. I try not to keep track of that too much because it slowly started to get to, well, how old are you then again? And today I'd like to talk to you about contract testing, give you a little bit of introduction about what contract testing is, what it can do for you, what it can do for your testing and your automation strategy, what it does not do, because contract testing is something that's slowly but surely starting to get some traction here and there. People are starting to talk about it more and more. It is definitely an interesting development. And so yeah, but there's still lots of people say, well, what is it? What can it do for me? What can it not do for me? How does it fit into my overall testing and automation strategy? And those are some of the questions that I hope to try and shed some light on for you in this next, I don't know how many minutes. As I said, I've not timed this talk for anything. We'll just see how long it takes. If it takes too long, Acharya is surely going to just cut me off and say, well, you've been talking for long enough now. I'm also going to show you a quick demo of how contract testing works in Java. In this case, it's by no means a complete and very polished and very smooth demo, but at least you can see what a consumer-driven contract testing flow looks like. So at some point during the presentation, we'll switch from PowerPoint to something with code. So what contract testing? First of all, how did this whole contract testing thing emerge? How did it start to exist? Well, years ago, and most of you will probably remember this, applications were pretty much monoliths. Yes, you had a UI, you had business logic layers, you had data access layers, you had databases, you had everything, but it was all very tightly interwoven, very tight coupling between these different components, these different layers of an application. So that meant that if something changed in the UI layer, for example, or something changed in the business logic layer, that required a rebuild and redeployment of the entire application. And you still see this a lot nowadays, but slowly but surely, people and teams and organizations are starting to move away from this traditional way of building applications towards architectures that look much more like this. And typically these are referred to as microservices-based architectures. Essentially what they are is Applications are built out of loosely coupled, sort of, kind of um, individual, independent components that communicate with one another through standardized transport protocols and message formats. So what you often see is a lot of individual components or APIs or whatever you want to call them that have one very specific task, and each of these components plays their own small role in a larger picture. So, for example, you have an individual component in a web shop that's responsible for handling everything there is to know about customers, and another component that handles everything with regards to orders, or to addresses, or to suppliers, or payment, or things like that. And so there are dozens more things I can think of. And in order to support the business processes that my application, that my piece of software is trying to support, trying to automate, these individual components communicate with one another through standardized, using standardized message formats over standardized protocols. For example, they use HTTP to communicate, and they use REST as an architecture with JSON as a message format. That's something that you see increasingly often, very common, and I'm pretty sure you've all seen it, worked with it, or you are working with it. So this is much more, this slowly becomes much more common. Of course, there are some advantages to this, to building and designing and building your application in this way. You have a lot more modularity. So as I said, with monoliths, if you want to deploy a new version of your application, you need to redeploy the entire application, including database and everything. With microservices, if something changes in a specific component, for example, the customer component, I only need to redeploy that customer component. I don't need to redeploy the entire application again. And that's a much quicker and more efficient process. Also, if I see that performance is lacking in handling my customer data, I can just increase the number of instances of that individual component without having to scale the entire application. So there's much more modularity there. Yeah, easier to deploy individual. So I basically already told that I don't need to redeploy an entire application. I can just redeploy an individual component. I can also swap out an individual component much easier if there's a better alternative available. If there's this, if I am building a component or service as part of my entire application, but somebody else is building something that does pretty much the same, but much better, I can decide to just swap out my own service for that third-party service, or maybe the other way around. I've been using a third-party service, but that doesn't live up to my standards anymore. I can just say, well, I'm going to rebuild that component in-house and use that one instead. That's things like that. Those changes are much easier if you talk about small components compared to having to redesign and rebuild an entire application. And of course, because applications are much more componentized, much more built out of individual components, it's much easier to tell team A, well, you're responsible for this component, and team B, you're responsible for that component. And you can do a lot of things in parallel. Of course, there are also disadvantages to doing this. First of all, because you have a lot of individual components that talk to one another through using network calls, there's a risk of a potentially higher delay, because there's one good thing about these tightly connected and interwoven layers is that when everything is in the same code, the inter-component and interlayer communication is pretty fast. With all these individual services that talk to one another through a network, there's a potentially higher delay caused by all of these network calls. Second of all, a design is really important, because once you've decided, well, this component is responsible for performing this task, and that component is responsible for that other task that also needs to be done, shifting these responsibilities is hard. So you need to really think about which component is doing what beforehand. Also, potentially you have a lot more tech stacks to maintain, because since these components are built out of, are communicating with one another through standardized message formats and over standardized protocols, it doesn't really matter anymore what language you build it in. So component A, service A can be built in Java, and component B in .NET, running on a .NET platform, and component C can be done in Go, for example, or Node.js or anything. And I'm not even talking about the different kinds of frameworks and framework versions and tool versions that you could use to build and run those, because they're all communicating with one another through standardized protocols over standardized, using standardized message formats. Pretty much every language and every tool out there is able to generate something that can use those, can communicate through those protocols and using those message formats. And the big one, end-to-end testing becomes more complex. And that's what I want to talk about today. This is one of the disadvantages of microservices-based applications, that end-to-end testing becomes more complex. Why does it become more complex? Because instead of just one application, one big monolithic application, I have all of these individual components that I need to spin up, that I need to make available when I want to do large-scale integration and end-to-end testing. All of these different components built by all of these different teams in all of these different departments or even organizations. I need to synchronize and coordinate the state that they're in, because I need maybe specific test data or specific behavior for the tests that I want to run, for the integration and end-to-end tests that I want to run. And so that picture that I've shown in the previous slide has like 5 or 6 components. That's incredibly small. In large applications, the number of components can easily go into the dozens or maybe even hundreds. I wouldn't want to be responsible for an integration or end-to-end test that has to spin up all these dozens or maybe hundreds of different components in order to create the initial state required for my end-to-end test. And so this becomes much more complex, really, because all of these different wheels, all these different cogs have to be in place and in the right place and in the right state before you can even start testing. Before we dive into contract testing and how this can help you solve that problem, the big question, at least for me when I talk about integration testing and end-to-end testing, is are all of those individual components that I'm testing, all these individual services, are they able to communicate with one another? Because that's basically what integration testing is all about. Do they all does this support my end user process? So and in order to be, hopefully we've already determined that each individual component does what it needs to do, because that's the responsibility of the teams that develop those components. But at some point, I want to make sure that all of those individual components and services are also able to communicate with one another, because it's useless if you have 100 different components that all individually work exactly like the specification, exactly as expressed in the specifications. But when you put them together, everything just melts and starts to malfunction. So this is for me the big question: that can they all communicate with one another? Are there no integration issues when I start combining them into something that supports my end user processes? Traditionally, the traditional way of doing this large scale integration testing and end-to-end testing is focusing on testing everything at once. As I said, spinning up all of these individual components, all of these individual services and things that make up my application, and running some typically pretty slow integration and end-to-end tests against that entire collection of individual components. So this is what a lot of integration and end-to-end testing looks like. Contract testing takes a slightly different approach to integration testing. Instead of focusing on the integration of everything at once, it focuses on individual integrations, on the integration of individual consumer and provider pairs. So on each individual pair of components that within the scope of that system communicate with one another. So it breaks down this enormous integration test where all of these different components have to talk to each other at the same time into these little integrations between each individual pair of a consumer and a provider. And that's also probably maybe the biggest benefit of contract testing. Traditional integration and testing is synchronous, meaning that all of those different components need to be in the right state at a specific point in time. Meaning that there needs to be a lot of coordination, a lot of discussion about I want to run my integration and end-to-end testing at this and this and this time, meaning that all of these different components have to be, first of all, everybody has to be done with development, or I have to do a lot of stubbing and mocking. And you could argue about, is it even a real end-to-end test then? And they all have to be in the right state at that specific moment when I want to run an integration and end-to-end test. So that's what I mean with synchronous. Everything has to be in the desired state at the time that I want to run my integration test. Contract testing is an asynchronous activity, meaning that each of the individual components, each of the players in this whole integration and end-to-end test activity performs their part of integration testing at the point of time where it's most suitable for them. I'll explain in a little while how that works and how they communicate with one another. The hint is through those contracts. But the big benefit of contract testing is that each of these consumers, each of the parties involved, can do their part of the overall integration testing activity as part of their own development and build and testing and release life cycle. So that's the biggest part. So contract testing basically breaks down integration and end-to-end testing in small chunks that fit the heartbeats, the release cycles of each individual component. Now there are two approaches to contract testing: consumer-driven contract testing and provider-driven contract testing. The difference between those two is who comes up with the contract, really. who maintains, who decides what goes into the contract. With provider-driven contract testing, obviously it's the provider. There is some benefit to doing that. It's not a technique that I see often in practice, to be honest. Most of the contract testing that I see and do is consumer-driven, because with provider-driven contract testing, it's basically when the provider is the one who creates the contracts, it's basically just the provider saying, well, this is what I do, and you just have to deal with it. That's it. It's not really a contract, it's just a description of, well, this is what I do. With consumer-driven contract testing, it's the consumer that specifies their expectations about how a provider behaves in a contract, hands that over to the provider and says, well, dear provider, can you please show me that you're able to fulfill my expectations, my requirements as listed in that contract. So that's a much more cooperative way, a much more democratic way, I would say, of doing contract testing, of doing integration testing. So as I said, a contract is an agreement or a set of expectations, really, between an individual consumer and an individual provider. So the consumer expresses their expectations about the behavior of the provider. For example, which are the endpoints that are available? What operations can I perform on this API exposed by the provider? What inputs do those endpoints expect? And maybe probably most importantly, what's the output that I can expect in return? How does the provider behave when I send them a specific request? So at the consumer, in order to be able to consume and process the data, the responses returned by the provider, the consumer says, well, and then if I want to be able to successfully process this, it needs to look like this. It needs to do this. It has to have a specific status code. The response body should look like this or that. So those are the kinds of expectations that go into a contract. Consumer-driven contractors, as I said, is a way to formalize this, is a way to, and the tools that support consumer-driven contract testing, with those tools, you can formalize these expectations in contracts, and then automatically, fully in an automated manner, check that the expectations that are expressed by the consumer can be met by the provider. So, and when all of those expectations are met, that individual consumer and that individual provider are able to communicate with one another. And that's not something that you find out just testing on the provider side or just testing on the consumer side. There's this whole communication integration thing that needs to be verified, and that's what you can do with using these contracts. One of the biggest benefits for the provider parties in this whole consumer provider ecosystem is that they can develop and refactor without fear, because as long as they are able to fulfill all of the expectations in the contracts, it doesn't really matter what their code does, how it's built, or what it does, because they know what their consumers, the parties that consume their API, what they expect of that specific provider. So as long as they meet, they're able to verify and show to everybody who's interested that they are still able to meet all of those expectations, they can pretty much do whatever they want. And for the consumer, obviously, it's a way to build trust. They can trust the providers to keep working. So And that's also a big part of integration, trusting that, having a mechanism in place that informs the consumers in case a provider changes something that breaks the contract, or that um, that something that triggers a malfunctioning in the integration between consumers and providers, really. The way Pact works, which is Pact is basically the de facto consumer-driven contract testing tool out there. There are a couple of others, most notably Spring Cloud Contract. Pact has a couple of benefits, I think, over Spring Cloud Contract, and the biggest benefit is that it's available for a wide range of programming languages, whereas Spring Cloud Contract is JVM only, and even and within that whole Java JVM ecosystem, it's really closely tied to Spring Boot. So unless you're doing using Spring Boot for all of your consumers and all of your providers, Spring Cloud Contract is using that is pretty limiting and restrictive. I have no comments about the actual quality of Spring Cloud Contract. I've never really used it, but I see that as a big drawback. Pact, on the other hand, is available for a wide range of languages, including Java, C#, Go, Python, JavaScript, obviously, PHP, and a number of others. What Pact does is, and how Pact makes contract testing as asynchronous, is it is able to generate from the contract, generate a mock provider, so which is used on the consumer side to test the consumer implementation. And also from that exact same contract, it can create a mock consumer, which can be used by the provider to verify that their current implementation matches all of the expectations that are expressed, that are written down, so to say, in that contract. And again, this is not a synchronous process. So the consumer can do their due diligence, their part of their integration testing responsibilities as part of their own build lifecycle. And the same goes for the provider. They don't have to wait on each other anymore to be in the right state at the exact same time to perform this integration testing. They can do their part, their response, and their part of the overall responsibilities as part of their own build cycle. And that is a big benefit, because you don't have to wait for all of these other parties anymore. And also because it breaks down integration testing into these smaller, almost bite-sized components, parts, little tasks. It's also a much faster process. The traditional integration end-to-end test can take minutes or even longer, and verifying a couple of contracts is a little slower, but not much slower than running unit tests. So what does it look like in practice? So I promised you a short demo. This is a project that I've built up just for demo purposes like this. It consists of 2 individual consumers. So this is within the context of a web shop. I have a customer API, a customer component, and an order component. And both of these parties, both consumers, they consume an address API. This address API is exposing data related to addresses that are either related to customers. So those are billing addresses, for example, but also related to orders. Those can be delivery addresses, for example. So it's important to remember both these API, they consume the same address APIs, because this address API contains data about both delivery and billing addresses. And now those might be the same addresses, but it doesn't necessarily have to be the same. I'm using, this is all written in Java. As I said, the example, it uses the JVM bindings of Pact. And basically how it works is, so for example, there are a number of tests here on the consumer side. So it's it's the consumer who generates the contract. And a contract is basically a list, a collection of expectations that a consumer has about how a provider behaves in certain circumstances. So in this class, the contract tests around the retrieval of addresses, so getting addresses from that address provider. I have a number of expectations for 3 different situations, 3 different interactions. So the first one is the interaction where I request data for an address and that address exists. The second one is where I request data for an address ID that does not exist. And the third one is for an address ID that's not correctly formatted. So there are 3 different ways in which the address provider can respond in each of these situations. So for the situation where the address ID exists, I have a number of expectations. So for example, the response should contain an address type field and its value should be of type string. It should contain a house number, which should be an integer. The zip code should also be an integer. And this one is situated in the US, and US zip codes are all integers. I have an ID, which is a UUID. So I'm using those expectations about what the response body looks like when I'm building my pact, my set of expectations for this specific interaction. I'm also saying, well, if it's a get and the address ID matches an existing address, I expect an HTTP 200 and a body that has this structure. I've done something similar in case there's an address ID which is correctly formatted. My address IDs are UUIDs, so but it's not found, then you get a 404, and I have no expectations about the response body because I'm not going to process that one as a consumer. And this, if the address ID is incorrectly formatted, I expect an HTTP 400 indicating that there's something wrong with my request. These expectations are, the way Pact works is they are written to the contract when you run your unit test. So it requires you to run unit tests on the consumer side. So that's often the first hurdle of implementing this, to be honest, is it requires you to write tests. It requires you to write tests to verify the implementation of the consumer. I want, as a consumer, I want to know that in those cases, should the provider respond in the way that I expected, I should also be able to process that response as required. So I need to test that too. And this is the running your unit tests here is the moment where the contracts actually get written, the contracts actually generated. So I have a number of assertions here that say, well, again, the way Pact works is that from the expectations, it generates a mock provider that behaves like you've specified as in the specifications, and it's your task on the consumer end to verify that you can process that expected response. So in this case, I'm just doing that using a number of simple assertions. And And the same for the default situations where I say, well, this should throw an exception with a 404 or a 400, depending on which situation I'm referring to. So again, running these tests, it takes a while. It's building. Running this test is not just running these tests has two objectives now. First, again, testing the consumer implementation, but also generating the contract. Really. So it takes a little while. I don't know why it's so slow. We can just cut this out of the recording, right? The whole waiting for stuff to build. But yay, the test passed. As you can see, once my machine is done compiling and building, running the test is actually pretty fast. So now I know that my consumer implementation is behaving as expected, but also, more importantly for the subject that we're talking about here, it has generated a contract. And my contract is an agreement between me, the customer consumer, and the address provider. This contract is in JSON, which, as I said, Pact is available for a range of different languages. And this format is standardized, at least within the realm of Pact, which means I can also exchange contracts between consumers and providers that are built in different languages. So if the consumer is built in Java and it generates a contract, that contract can be verified by a provider built in C# or in Python or in Go, as long as they all use Pact and they use the same version of the specification, or at least the compatible version of the specification. This contract, I've run 5 tests. This one contains 5 interactions, and an interaction is basically a segment specifying the expectations for the consumer for a specific interaction. So this one is for I've also included 1, 2 for the HTTP deletes. Here's the one. If I do a get for an address, for this address, I expect a 404. Here I expect the 400, and this one is the longer one where I expect. And these are the examples used to generate the mock provider responses and the mock for the consumer unit testing. The actual measuring rules say, well, because I've used the string type and integer type here, matching methods here, which say, well, I don't really care what the value of this address type field is, because that can change from and depending on certain things, as long as it is a value of type string, and that's what's expected expressed in the contract here as well. For example, for the address type, it should match the type of the example that's given here, and this is a string, so I'm expecting this address type field to be a string. For this UUID, this should also be a string, but it should be a string that matches this regular expression. So in this contract, I have a number of expectations from this specific customer consumer about the way the address provider behaves. Now, as I said, I've also got the order consumer, which also generates their own contract. I'm not going to show you that because it's pretty much the same as the customer consumer right now. What I can do, so this is still the responsibility of the consumer. So writing tests that generate contracts. And the second step is then give that contract, pass that contract to the provider, give that contract to the provider, so they can use it to verify whether they can meet the expectations. Now, in this example, I'm just going to do that using a simple copy and paste because it's just a JSON file. It's actually already here. I've got these two contracts here. So one from the customer consumer and the other one from the order consumer. And on the provider side, I've written some tests too, one for each state, for each interaction. So I could use these methods to set up the right initial state on my provider end. In my incredibly simple implementation for this API, that's not necessary. The initial state of the API is the correct one, but you could use this to do some additional setup here. But as I said, for this example, that's not necessary. So I have a test for each of the states in each of the contracts. As I said, I'm going to pick up my contracts from this specific folder. I identify myself as the address provider. And if I run this test, it's going to spin, in this case, it's going to spin up an actual local version of the API, of the provider API, to verify its behavior. But again, this is pretty quick. I bet you couldn't do 10 integration or end-to-end tests on a large scale within this time frame. And all of these tests pass, which means that in its current state, the provider is able to meet all of the expectations expressed by all of the two consumers right now. For example, if say a customer has a different expectation, I'm just going to quickly change the contract. Say, well, for a delete, when I'm deleting an address that exists, I expect an HP status code 204, which is the way the provider is implemented right now. Say, well, this customer consumer now expects a 201 or a 200, for example. And I run the contract test again. So let's say the customer has a different, the consumer has a different this consumer has a different expectation right now for this specific operation with this specific state. Running the tests again, as you can see, the first one, 9 operations still work, but this one fails because given for this specific initial state, when a request to delete an address comes in, something's wrong with the response. Something's not what I expected. And I said, well, I just quickly rewrote the contract to express some different behavior, but Pact at generating a mock consumer from this contract and invoking the actual provider detected, well, in this case, in this specific path for this specific interaction, there's a problem now. And that's basically in a nutshell how Pact works. And it works the same no matter if you're using the Java bindings or the .NET bindings or Python or whatever. Yes, the syntax is different, but the feature and the flow is the same for each of these bindings. So in this quick demo, what I've done is just copying and pasting the contracts between the consumer and the provider. You wouldn't really do that in real life. In real life, you first of all, that's incredibly error prone, and maybe people forget to copy the newest versions of the contracts and the new email the newest versions of the contracts or whatever, or they get lost, or you mix up versions, stuff like that. You need a better mechanism for that. And the mechanism to do that is the Pact Broker, which is basically a repository of contracts. Pact Broker is a mechanism, a broker, as the name says, a kind of library repository for contracts. It's a man in the middle, process in the middle that takes contracts from the consumers, stores them, distributes them to the providers for whom the contracts are intended. And it also enables providers to upload the verification results. And that's really important, because then you can also, in the example that I just shown, we didn't really close the feedback loop, because there's no way for the consumer to know whether or not the provider can actually meet their expectations. With a Pact Broker, you can close this feedback loop, because a broker is also able to inform the customers, the consumers, about whether or not the providers is able to meet the expectations from the contracts. So the way this flow works is, the first step is the consumer generates and publishes a contract. The provider downloads that contract and verifies its implementation against the expectations. It publishes the verification results, and the consumer is informed of the verification results. So one of two things happen. Either consumer or the provider say, well, all lights are green, I can deploy now. Or they see, well, there's a problem here between consumer A and provider B for this specific interaction. And the broker even informs you what the problem is, and that's basically information generated by Pact itself. So you know where things went wrong and where there may be a clash of a conflict of interests between multiple providers that multiple consumers that consume data from the same provider, for example. So this is a screenshot of Pact Flow. The Pact Broker is available as an on-premise open source, so that's something that you can host yourself. Pact Flow is the cloud, the software as a service version of it. There's a free plan, but if you want to scale it, there are paid plans. So that's my first big disclaimer. But it's if you work with a lot of different parties that are maybe not always able to access the same on-premise instance of a Pact Broker, this might be a good solution. And it also has a nice graphical user interface in which you can see, well, at this specific contract between, in this case, a zip consumer and a zip provider, and the consumer published this version of the contract this long ago, and the provider with this specific its specific version verified this contract, so it uploaded its verification results and everything was okay. And you even get a nice network diagram which allows you to get some insights into which consumers and providers are still able to communicate with one another and where the potential integration issues are. So a couple more minutes, I promise you, and then I'll stop talking. So now you've seen what consumer-driven contract testing can do. There are also a couple of things that it does not do, or does not do well. So it is not meant to replace the testing of the implementation of an individual API, an individual provider. That's still the responsibility of the team that's responsible for developing the provider. They should still do functional testing. What contract testing does is testing whether a specific consumer and a specific provider are on the same page with regards to their communication. It is not about, this is not a replacement for tests you write using Rest Assured, or Postman, or REST-Sharp, or SoapUI, or whatever. This is something you do in addition to that. It's also not particularly well if you're testing public APIs, because with public APIs, it's incredibly hard to identify who your consumers are. And it's probably also incredibly hard to get them all on the same page with regards to the implementation of this contract testing approach, this consumer-driven contract testing approach. As you've seen, it requires adopting a tool and writing tests on both the consumer and the provider side. When you're writing public APIs and you don't really know who your consumers are, and maybe you've got hundreds or thousands of different consumers and they all have their own expectations, this is probably not the best approach for you to do so. What I like about the people behind Pact, apart from that they're really nice people, is that their documentation contains a lot of good advice and suggestions on when to use their tools, when to use their products, and when not to. So docs.pact.io is a great starting point if you want to know more about consumer-driven contract testing in general and Pact as a tool specifically. And this specific page tells you a lot about what are situations where Pact shines, where consumer-driven contract testing shines, and situations where it might not perform as well. Yeah, that pretty much concludes what I have to say. But before I give control back to Akshaya to see if we have any questions, let me give you some useful resources, because as I said, I can't explain everything there is to know about contract testing in just under an hour. Okay. I mentioned this one already, docs.pact.io. They contain wonderful documentation about Pact as a tool, tutorials, examples, but also a lot of information about contract testing in general. So they go beyond just describing what their tool does. They also describe pretty well, at least in my opinion, about what consumer-driven contract testing actually is and where it can help you and what kinds of problems it is intended to solve. If you want to hear a similar story from from somebody else, this is the first post in a 4-part blog post series that really helped me understand what contract testing really is all about. I read that a couple of years ago. It's written by some great folks at Kreuzwerker, which is a German IT consultancy company, and they wrote some really good. They wrote down their experiences with introducing consumer-driven contract testing using Pact at one of their clients. So that really gave me a good insight into what CDCT actually is, how you can use it, what the benefits are, what the drawbacks are, which problems they ran into, and so on. The creators from Pact themselves, if you are more of a video watching person than a blog post reading person, the people behind Pact created a 4-part video series on consumer-driven contract testing. The first one explains the problem with end-to-end integration tests, which is what I addressed in the beginning of my talk as well. The second one introduces contract testing and how Pact works, which also was I tried to cover in this talk too. The third one gives a similar demonstration, but using the JavaScript bindings of Pact. And the fourth one is more to convince you that, well, how does this replace all these expensive and slow and hard to maintain end-to-end tests? So that's out there for you to watch as well. And the final one is a blog post series that I am currently in the process of writing myself. It's going to be 6 or at least 6 articles. I've just published number 3 earlier this morning, and it is first of all, it's meant to help myself at getting my facts and improve my explanation of what contract testing is and does, but also to give people some working examples. So these blog posts also link to the examples in Java that I just used in the demo, so you can try that out for yourself as well. And that's it, really. Oh, just under an hour. That's a little longer than I expected. Are there any questions, Akshaya or Sandeep?
Yeah, there are some questions. I noted down. Maybe you can stop sharing. I can just start the questioning round. Some question. Sure. Yeah. First of all, thanks. There is a really nice talk, Bas, for your time, and Matt also. He somehow found you in the time zone to talk about this cool topic. Yeah. So some questions I can just read out.
Sure.
One is regarding the performance test. So, like, what is the best way to do the performance testing for microservices? And we can't run test on a specific microservice, as the service could use multiple API calls to other microservices. Yeah.
I don't think I am the best person to ask that question. I am not very experienced in performance testing, to be honest. Mm-hmm. It's also not something that you can cover with contract testing. Contract testing really is about functional integration between individual consumers and providers. I think this is actually one of the bullet points on the Pact side, is what not to use Pact for. I would of course still be happy to answer this question if I had a good answer, but I am not a very experienced performance test engineer, so I'm probably not the best person to answer this one. I'm sorry.
Actually, you are on mute.
Sorry. Yeah, I can tell you, like, Bas, maybe you remember Coding. He's also a famous speaker. He spoke about Selenium for talks. He told me
who?
Coding.
Oh, cool. Yes.
So yeah.
Of course I do.
Yeah, I know him, and he suggests me using a Gatling. And one of the answer I see here, you can mock all the external services and just do the performance testing of your microservices using Gatling.
But as you said, that I've sort of kind of used Gatling, not really at scale though. But it's a great tool. What I like is that you can express your performance tests in code. I really like that, which makes it really easy to make that part of version control and build pipelines and stuff like that. But yeah, if you use one of the important things to consider if you're using mocks for these downstream APIs is that you don't just mock the functional behavior, but also make them behave realistically in terms of performance. Most mocking tools are able to do that by saying, well, the typical response is returned between 200 and 500 milliseconds or something like that. So most tools can do that. One of the tools that directly comes to mind is WireMock, I know WireMock can do this. And I'm sure other tools can do this as well. It's just part of the behavior that you're modeling, but you really need to be really careful. Is what's the realistic performance of these downstream services, and make sure that you model that accordingly. I think you've muted yourself again.
This is how it's working. Sorry.
No worries.
I can share that link of Gatling, but I referred because I'm also planning to how we can keep the performance test in the pipeline. Yep. Okay. Yeah. Second one is from the Dario. Did I get it right? In case my API is used by 100 different services, I would need them to write the contract. So basically, to introduce consumer-driven contract testing is not in my sphere of influence in the end.
That is a very good question. No, you need to get the need to get the other parties on board too. And that's also why it is so hard to do this for public APIs, because your consumers can be literally anywhere and you don't know who they are. But yeah, it's not something you can just do as a consumer. You can generate all the contracts that you want. If nobody's going to verify them, it's not really very useful. You can say, I do contract testing, yes, but the other end of the line doesn't. That doesn't really bring any value. So you need to bring them up to speed. Do you need to involve all consumers? No. The more the better, of course. But it's already adding value if you just implement it for one consumer and one provider, because you can make sure that that consumer and that provider can communicate with one another at all times. What the other 99 consumers are doing, you don't know yet, but you don't have to bring them all on board to start adding value to your development process. The more the better, of course. But
okay, thanks. Let's go to the next one. From Zerky. Still confused about microservice, and does it mean that in a microservice there are multiple API endpoint? I partially answered that, but yeah, you can.
It can be. It depends on the responsibilities for that individual component. So a component in a microservice, and typically, if you do it well, has one responsibility. So, for example, in my example, the address API handles everything there is to know about addresses. It could have some downstream, in this case it doesn't, but it could have a zip code resolver, for example, or something like that. But its responsibility is managing address data. And to manage address data, you need to be able to read them, to create new addresses, to update existing addresses, and maybe to delete addresses. So there are multiple endpoints, but they all are related to the same responsibility, the same task, which is managing addresses. I saw one question pop up just now. I'm not sure if you're doing them in chronological order, which I do want to address. Shall I do that right now?
Yeah, sure. No problem.
I saw a question pop up, and I'm not sure if this is a literal quote. Can I do something like this using Postman or Rest Assured or Karafi?
Yeah, I see.
Yes. You, or at least that is the direction that the Pact Flow product is going in the near future. So right now, Pact Flow only handles contracts generated by Pact and that are verified by providers that also use Pact to do so. There is this wonderful blog post, and I'm just going to look that up and pass that in the chat. Which is, the one about bidirectional contracts. That is basically the direction in which the Pact Flow product is going, and what it means in a nutshell is the long version is in that blog post. But basically what it means is in a nutshell is that you don't have to rely on Pact as a tool anymore to be able to generate and verify contracts in consumer-driven contract testing. This new direction will allow you in the near future to also generate contracts from and verify contracts using tools like Karate, Postman, Rest Assured, WireMock, things like that. So that means that, and why they've done this, why they've decided to start building and supporting this is because it makes adoption of the contract so much easier. Because right now, adopting Pact means you have to, adopting consumer-driven contract testing means you have to start using Pact both as a consumer and a provider. So, and this new direction, which also means that it doesn't actually have to be the consumer anymore who uploads the contract first. So it's really, that's where the bidirectional terminology comes from. It allows you to extend the scope of your contract testing activities also for parties that do not use or do not want to use a tool like Pact.
But how this tool will generate on as a real time that Pact JSON, it will not, correct? We need to provide them some of the configuration or the JSON so that they can read and test it.
They were what is going to happen, and there is an example available. There are some examples available already. I must say I haven't played around with it myself yet. I should start soon because this is the subject of the final post in this blog post series that I'm going to write.
Actually, I tried it via the Postman. Via the Postman, I tried it, and somehow I just able to validate only the JSON schema, not much more about that thing with the help of the Postman. I am also trying to do this same exercise.
Okay, so what they are going to supply is adapters that allow you to generate Pact-like contracts. So contracts that follow the Pact contract specification without actually having to use Pact.
Yes.
So, but as I said, I haven't actually played around with that myself yet because I haven't found time yet. But it is definitely an interesting development.
Yeah. But I have one question regarding this provider. As we are doing all the assertion from the consumer side, is there any way to do on the provider side as well? Or in the provider only we just hit to the actual host with the endpoint and just verify with respect to contract only? That's the only thing.
That's the responsibility of the contract testing part. On top of that, you should still test your provider implementation itself. So that's not something you do here. The only thing I'm doing on the provider side here is checking if it meets the expectations that are written down by the consumers in the contract, not if the provider works according to the specifications that are written up by the provider team itself. That's something you can still do using Postman, Rest Assured, whatever.
Yeah.
So and this is something that comes. It's both and, not either or.
Okay, got it. And one more thing, and actually in the company standard, this provider and consumer should be on the separate repo instead of the single repo, and it should be on the developer, reside inside a developer repo, correct? Where the actual API is written. Is it a tendency or something we just separate out the different repo, make a different repo for the contract, and from the initial we can write it? What's the good approach? Yeah.
I'm not sure if I understand your question correctly, but typically the consumer and the provider are in different repositories. Yes, I've just put them in the same repository here in the demo because it's much easier, because I don't have to switch projects. Typically they are in different, they can even be written in different languages. And that's where and for the distribution of the contracts, that's where a Pact Broker is incredibly useful, because you can just automate not just automate the running of the unit tests, but also you can tell on the consumer side, you say, well, after running these tests, automatically publish the contract to the broker. And then the provider can just say, hey, I'm going to see if I can fulfill all of the expectations that are written down in all of these different contracts. They can automatically pull the latest versions or the correct versions from the contracts from that same broker. So as long as both repositories, or rather both machines where both the consumer and the provider are built, have access to that central broker, to that central repository, everything should work. I hope that answers your question.
Yeah.
Yes, thanks.
Yeah. And is there any question that someone wants to ask particular? Just drop. Otherwise, there is some question which tool they could prefer, like Pact or Spring Cloud.
Yes, I stopped saying, well, you should use this tool a while ago. I'm typically using Pact. Why? Because it's available for so many languages. Spring Cloud Contract. I have no experience using Spring Cloud Contract. I know it's out there, and I know it's tied to the Spring Boot framework.
Yeah.
Which means that if all your services are built using Spring Boot, it may be a wonderful tool. It may be 100 times better than Pact. I don't know. One big benefit of Pact is that you can use it in a heterogeneous environment where party A is built in Java, party B is built in .NET, and stuff like that. I don't know if it's better than Spring Cloud Contract. I know that I think this is a big advantage, but I've never really used Spring Cloud Contract, so it would not be fair of me to compare the two. And you know how it goes with tools. Everybody's saying that their tool is the best. I am not doing that. There's maybe a best fit for a specific context, but as I find myself saying increasingly often, it depends.
True. Okay, one question we have from Robert. I know contract testing can be also used for message integration, but these integrations are often using schemas between the services. Would it be redundant to add contract testing to such integration with the schemas?
That is a very good question. And the answer is, it's probably much better answered on the Pact website. I know that there's a whole section to this, but what if I do, and what if I use schemas? Schemas are much more static. Schemas don't enforce verification between on both ends, and consumer-driven contract testing does. It makes this whole integration testing thing much more. If you can ensure that all of your schemas are verified by everybody all of the time, and that there's some way to inform all of the parties that everybody checked that they can all confirm or can all conform to to those schemas at any given point in time, that could work. With contract testing, that's part of the process. So I think that makes it a bit easier. But again, like with which tool should I use? If schema testing works for you, that's a perfectly fine thing too. I just think that the whole process behind contract testing is a little more, a little easy, a little easier to get that integration testing value out of. But again, there's this whole, I think there's now I'm going to look it up while you ask the next question.
Yeah, we have one, I think one last question, and Jayesh already asked all the questions by himself. How are the contracts getting exchanged from customer to provider?
Via email? No. That's what the Pact Broker does.
Yeah.
So what I've not shown in this demo, but there are, so for example, for Pact Java, for Pact JVM, there are Maven plugins which you can then just invoke and say, well, now publish all of the contracts, and they are then uploaded to the broker, which keeps track of the contracts and the versions of the contracts and at what time they were last verified. And when it's the provider's turn, they can just pull the relevant versions of the contracts from that broker. Also fully automated. That's just part of the code. So in the example, I've shown you a packed folder annotation, which pulls them from a local folder. There's also a Pact Broker annotation, in which you just specify the host name for the broker and your authentication token, and it pulls those same contracts.
I think I covered all of the question, and if I don't, just you guys can just raise your hand. I will allow you to just ask question. I have one question to you. Like, I saw the demo is between the microservices, consumer driven testing, but it is possible also to use with the front end is your consumer and back end is a provider, and so that we can have a contract between the front end and the back end. Do you have some examples, or did you experience this kind of or only between the microservices?
No, you can use this between front end and back end as well. If you use your front end is typically your consumer then, and your back end is your provider. You can definitely use Pact there as well. The need for it might, depending on how your team or organization is organized, the need for it might be less urgent, because if the front end and back end is developed in the same team, integration issues are just less likely because communication is easier.
True.
Still, that doesn't mean it can't provide value, but and you can definitely use it, but it might be less urgent.
Got it.
But it's still again it's something that can definitely be done. Yeah.
I was thinking of just trying this thing also, like with the front end and the back end. I think that's it.
I found the link that I was looking for. Regarding the question using the schemas, let me just paste that in the chat as well. So I was multitasking, I'm sorry. I am not equipped to do that, but I did it anyway. So this convince me page has a lot of reasons why the people who created Pact thinks that using Pact is a good idea. And one of the and they are pretty, they're not selling any, it's an open source product really, but they give some answers to often asked questions, and this is one of those questions. So, but what if I use contracts?
Cool. I think that's it. And we have, I think the participants already left. So we have a small poll, I think, that I can do in the next meetup, in the next